Okay, I'm here in Module 1, Topic 3 review. Here are some key terms on linear and nonlinear. If it's a line, it's a linear graph. If it's not a line, it's non-linear. If it's linear, then it can be proportional or non-proportional. If it's a line and it goes through the origin, it's proportional. If it's a straight line and does not go through the origin, it's non-proportional. All right, so in these first three here, you're describing the graph. Select all that apply. This one is a straight line, so it's linear, and it goes through the origin. It goes through the point 0, 0. So you're going to check linear, proportional. And number two, it's a straight line. It's linear, but it does not go through the origin. So this one is linear, non-proportional. It does not go through the origin right there. And then in number three, this one's not a line, so it's just non-linear. And if it's non-linear, that's the only thing we select. We just select non-linear. And number four here, the student is studying the same amount each day. And so basically we have a constant rate of change. There's the same amount each day. She studied for 4 days for a total of 60 minutes. So if we take 60 and divide by 4, that will give us the average number of minutes that she studied each day. 60 divided by 4 is 15. Right? So on day 1, she studied 15. Day 2 was 15. Day 3 was 15. And day 4 was 15. So our constant rate of change, our constant of proportionality would be 15. Okay? And so since this is a proportional relationship, we can use the equation y equals kx, and we take k and plug it in to this equation. And so y equals 15x would be the equation to represent this relationship. Number 6 here, why does this graph show a proportional relationship? Well, it's a straight line that goes through the origin. Okay, it's a straight line that goes through the origin, so you'll select that last option right there. Number 6, which of these has a constant rate of change? All right, so which one has a k? And so what you have to do here is you have to check each pair. So I'm going to check this pair. Remember that k is equal to the y values over the x values. So I'm going to take my y value. If the top is x and the bottom is y, I'll take my y value of 40 and I'll have 40 over 2. 40 over 2 is 20. Then I have 60 over 7. 60 over 7, that is not 20. I'll just put does not equal 20. Okay? And so because there's not a consistent k, I'm not getting the same number every time I put my y value over my x value. Table A is out. Okay? Go on to table B. 40 over 2, we said was 20. 140 over 7, 140 divided by 7, this would be 20. 280 over 14, 280 over 14 would also give us 20. Okay, so each time we got 40 over 2, 140 over 7, and 280 over 14. That all gives us 20. And so, yes, we have a constant rate of change here. Our answer would be B. We can eliminate C. 40 over 2 is 20, but 70 over 7 is 10. And so C also does not have a constant rate of change. Number 7, find the K. So to find K, you take your Y's over your X's, take this over this, this over this, this over this, this over this, right? Check each pair. So 250 over 25, that is 10. 500 divided by 50, 10. 750 divided by 75, 10. And 1,000 divided by 100, 10. And so 10 is our constant of proportionality. So just put the number in, just put 10. Number 8, is this relationship proportional? How do you know if a relationship is proportional? There is a constant rate of change, right? There is a constant rate of change, and so you got to find K. K, again, is equal to Y over X. So you have 12 over 2, 36 over 6, 48 over 8, 72 over 12. If you take those Y's and put them over the X's, do you get the same thing each time? If so, that is your K, and then you would plug K into the equation Y equals KX. Whatever K is, plug it in there. Number 8, write an equation for this relationship. Now be careful here. Remember, we have to find K in order to plug it into the proportional relationship equation. So K is equal to the Y values over the X values. So watch here. I'm going to take 1 over 3. This is the fraction 1/3. This is not 3. 3 over 1 would be 3, but this is 1 over 3. Next, I have 2 over 6. or the fraction 2/6, which is also equal to 1/3 when you simplify the fraction. Then you have 3/9. This is 3/9. 3/9 is also equal to 1/3. Last pair to check, 4/12. 4/12, or 4/12 is equal to 1/3. And so as you can see, we have our k being equal to 1/3. And what this is saying is that the y values are 1/3 of the x values. Okay, so in this equation, y equals kx that we can use to describe proportional relationships, we take what k is and we plug it in right there. So y equals 1/3 x. That's the equation that you will choose. What is the constant of proportionality? So remember, in the equation y equals kx, k, the constant of proportionality, is the number directly in front of x. It is the number being multiplied by x. So in that case, it would be that number right there. And number 11, you don't see a number right there, do you? What number is in front of the x? Remember, if you don't see a number in front of the x, it is an invisible 1 that you should make uninvisible, right? So the k here is 1. Number 12, which equation shows the relationship between fuel used and distance? You need to write their ordered pairs. Okay, so the ordered pair for this dot would be 1, 20, right? 1, 20. Then you have the point 2, 40. So 2, 40. Then you have the point 3, 60. 3, 60. And finally, you have 4, 80. Okay, so there's your ordered pairs, your points, which are made up of x values and y values. And to write an equation to represent this relationship, you need to find k. So take your y's over your x's. K is equal to y over x. So this would be 20/1. That's 20. 40 divided by 2 is 20. 60 divided by 3 is 20. And 80 divided by 4 is 20. So k, it looks like, is 20. And so that's what you're going to plug in to the relationship y equals kx. Take your k and plug it in right there. And so y equals 20x. Y equals 20x. And so what this is saying is that the distance is 20 times the fuel used. And that's what you're going to use that knowledge to help you in number 13. So if y equals 20x and x right here represents the gallons used, then if I want to know how many miles I can travel with 5 gallons of gas, I plug 5 in for x. And if I plug 5 in for x here, this is 20 times x, or 20 times 5. And of course, that would be 100. Okay, so that is the number of miles that I would travel, 100 miles on 5 gallons of gas. And finally, number 14, Carly works at a restaurant. She earns this much in 3 hours and this much in 5 hours. And so which equation represents the proportional relationship? Well, you need to take your cost, 49.50, over the number of hours. What's 49.50 divided by 3? That will give you some number. And then take 82.50 and divide by 5, and that should give you the same number. And so this would be your k. And so that's what you're going to plug into the relationship y equals kx. Whatever k is, put it in right there, and then select which one of these that it is. Once you have finished, go ahead and click submit. View the ones that you missed if you missed any. And then if you did miss any, fix your responses, right? Edit your response until you get all problems correct.